Okay, in this video we'll be looking at graphical connections of f, f prime, and f double prime. We're not looking at any algebra here. We're just given a graph. We're not going to worry about any of the, taking the derivatives or anything like that. We're just going to read this graph. Okay, so what we have is a graph of f prime. This is pretty common. Notice this is not f, this is f prime, but primarily the questions you're going to be asked are going to be f. We're going to ask questions about f like, for instance, where do we have critical points, whether those critical points are relative maxes or mins or neither, and then number two, determine intervals on increasing and decreasing. And then we're going to answer some things dealing with concavity as well. Okay, so let's start off. The first question is pretty easy. We know that we're going to get critical points whenever f prime equals 0. This is f prime. So I'm looking any place where this thing touches or crosses the x-axis. So we have critical points at x equals -3. And by the way, these are all ones. Notice I don't have y values because the y values don't really matter a whole lot for what we're doing here. So x equals -3. X equals 0, and x equals 2, and that is because f prime equals 0. Once again, as we do these problems, be sure to justify. Your justification is very, very important with these problems. So these are our 3 critical points. Now our next thing is to determine whether our critical points are relative maximums, relative minimums, or neither. The one thing we want to realize is that this really does the same thing for us as a sign chart does, because this is f prime. So to determine whether f prime is positive or negative, it's very easy. If it's above the axis, it's clearly positive. If it's below, it's clearly negative. What we don't want to be looking at for this is what the slope of this is. Keep in mind this is f prime, not f. Okay? So what I realize is x equals 3 is neither. So there's neither a max nor a min at x equals -3, and that is because f prime doesn't change sign. Does not change sign. Okay? X equals 0, notice our derivative's going from negative, right? The values over here will be negative, the values over here will be positive. So if my derivative goes from negative, that means f is going from decreasing, and then to positive, f prime is going to increasing. So it's going, so f prime going from negative to positive means we will have a relative min. Do not have a lot of room here. So we have a relative min at x equals 0, and that is because f prime goes, and that's going to be negative to positive. Okay, forgive me for this cramped space over here. And then finally, let's do this one over here. We will have a relative max at x equals 2, and that is because f prime goes positive to negative. Positive because above to negative below. Okay, so that is the end of question 1. Now question 2, once again, quite simply, this takes the place of our sign chart here. This one does have a little bit of a complication for the decreasing, which I'll talk about over here. But for the increasing, it's quite simple. When f prime is positive, our function is increasing. So we know that f is increasing from 0 to 2. So we're increasing. I'm just going to make a upward arrow like this. We're increasing from 0 to 2, and that is because f prime is greater than 0. Oh, another thing I should have mentioned is typically these things will be defined on an interval. So this is f prime on this closed interval, -4 to 4. So it doesn't continue on or anything like this. So as we do these intervals, we want to stop at these endpoints, and that's pretty typical. And then finally, this thing will be decreasing. Now here's the thing. Notice at this point, it's going from negative to negative. if we have that where there's an instantaneous point where it goes negative to 0, negative, or if it went positive, 0, positive, that point where it goes 0 instantaneously has to be included in the interval of decreasing, or conversely, in another case, increasing. So we actually have one big interval of decreasing here. So we're increasing from -4 to 0. Now what I can't just say is f prime is less than 0, because of course it's not 0 there. So I want to say that f prime is less than 0, and that's -4 to -3, and then -3 to 0. So if it has an instantaneous point where it goes 0 but goes negative and negative, that -3 will be included in that. This does get a little confusing, just try to keep that in mind. In general, it's very straightforward. If f prime is negative, it's decreasing. If f prime is positive, it's increasing. That is the most common thing. Okay, and then we have one more interval of decreasing. Hopefully you can still see this down here. Our last interval of decreasing is from 2 to 4, and that one is pretty straightforward. It's just because f prime is less than 0. Okay, so these are the questions. So critical points, and whether it has relative max, min, or neither, and then intervals of increasing, decreasing. It's just a matter of reading f prime almost like it's a sign chart, right? F prime is negative, negative, positive, and then negative with critical points at -4, 0, 2, and 4. Now we're going to look at how we determine the double derivative here with concavity for question 3. Okay, question 3, determine intervals where f is concave down, or excuse me, concave up and concave down. Also find x values of inflection points. Okay, so keep in mind, as we've been talking about, when we talk about concavity, we look at the double derivative. So if our double derivative is positive, it means we're concave up. If our double derivative is negative, it means we're concave down. If our concavity goes from concave up to concave down, or vice versa, that means we have an inflection point. So this is what we're looking for here. So we want to read f double prime. So keep in mind we're giving f prime. So f double prime is the derivative of this, and derivative is slope. So when I see the slope is positive for here, I know that f double prime is positive, which means that f is concave up. So we are going to be concave up when f prime is increasing. And that's what I want to use here. I want to talk about this. So f prime is increasing from -4 to -3, from -1 to 1, and that is it. And I would simply say because f prime is increasing. If you did say that f double prime is greater than 0, that does mean the same thing. F double prime greater than 0, since that is a derivative of that, I do accept that. But I will tell you that there are questions I've seen on the AP test where they ask you to specifically use f prime. So that's why I will talk about the graph I'm given here. So concave up for f from -4 to -3, that is because f prime is increasing. And then from -1 to 1, and that is once again because f prime is increasing. Concave down. Okay, so we're concave down when f prime is decreasing. So from -3 to -1, and then from 1 to 4, and we would say when f prime is decreasing. Okay, so those are our intervals of concave up and concave down, and now inflection points come right from that, because anywhere we have a switch from concave up to concave down, what we have is inflection points. So concave up, concave down, and then that means we have inflection points at x equals -3, x equals -1, and x equals 1. And what we would say here is because f prime goes from increasing 2 decreasing, or vice versa. We just need that change in concavity there. Okay? Okay, so that's about it. So that's question 3. Now for question 4, what I'm going to do is I'm actually going to sketch F. So let me talk about that. All right, so for question 4, what we're going to do is we're going to sketch F prime, or excuse me, we're going to sketch F using F prime. The key word here is sketch. We're interested in the general shape here. We really do not need this to be all that accurate. There's actually only one value I know for sure, and that's the F of -4 is equal 4. So I will mark that on here. But notice I didn't put any of the other marks here. It really is not going to be clear where it crosses the x-axis. I'm looking for the general shape of this thing. Okay, so if you look at what we answered on questions 1 through 3, basically everything we need to give a general shape of this comes from that, whether it's increasing, decreasing, concave up, concave down. That's generally what I'm looking for here. Now, when I'm looking at something like this, what I tend to do is I keep track, because it can be kind of confusing. So the way I organize this on the graph. Above, I'll keep track of when F is increasing or decreasing. And below, I'll keep track of when it's concave up and concave down, okay? How do I know what F is doing from -4 to 0? Well, I know since F prime is negative, it does have that one 0 here. But I know that since it's negative here, I know it's decreasing. Now the 0 here, where F prime is 0, that means it sort of takes a break. It has sort of a plateau, so it's going to decrease, go 0, and then decrease again. So I'll mark that with a little horizontal arrow, and then it's going to decrease again. So decreasing goes 0 instantaneously, decreasing. Now from 0 to 2, it's increasing the entire way. And then from 2 to 4, it's decreasing. So first of all, keep track of whether it's increasing or decreasing. You know what, let's put this on here, because I think that will help. So -4, so it's decreasing, goes 0, decreasing, and then at 2, 0 to 2, increasing, 2 to 4, decreasing. Okay, I didn't put numbers on here. Okay. Now below, I'll keep track of concavity. Keep in mind, concavity comes from the double derivative, the derivative of this, so I'm just looking at whether this function is increasing or decreasing. So -4 to -3, okay, this thing is increasing, so this would be concave up. So I just show a clearly concave up thing. So this kind of gives us a visual representation of what we're going to see here. From -3 to -1, okay, it's decreasing, so that's going to be concave down. From -1 to 1, it's increasing, so that's concave up. And then from 1 to 4, it's decreasing, so that's going to be concave down. All right. Now, if I take a look at all this, I want to make sure it sort of matches the increasing, decreasing up here and the concavity here. And just do the best you can with this. We have to use this point. So we're starting with this point. We're concave up. We're decreasing. So that's going to look something like that. By the way, don't worry about where we are in relationship to the x-axis. Now, as I mentioned, it has sort of this plateau point. So it just sort of stops there for a moment. It's not increasing or decreasing. It technically is part of an interval of decreasing, but it kind of goes flat there. We're still going to decrease after that, but now we're going to concave down. Okay, so we're going concave down to about there. Okay. And then, really can't tell the difference between this is supposed to be yellow. And then at this point, it's going to continue decreasing, but it's going to concave up. So we want to clearly show this transition from concave down to concave up, inflection point at -1. Now at this point, it's going to stay concave up, but it's increasing. Once we get here, it's switching to concave down, and it's going to stay concave down for the rest of the time. Still increasing until we get to here, and stays concave down, but now it's decreasing. And like I said, maybe you crossed the x-axis here, maybe you didn't. It really doesn't matter. We're looking for this general shape. When I grade yours, I will look at whether it looks like it's increasing when it's supposed to or decreasing. And I'll look at the general concavity. And then finally, we do have the 1 point, f of -4 is equal to 4. And that's it for graphical connections.